So good afternoon friends. Today we are going to see our another example, which is when a cable is subjected to a uniformly distributed load. And what if we have provided pulleys or a saddle at the support. So in that case we will see what are the various forces which is being generated in a cable as well as in towers also. So in this case I have taken a cable whose ends are at the same level. So let's start the example. As you can see here, there is a cable which having its both the end at the same level, and it is subjected to a UDL of 30 kN per meter, and distance between our two tower is 80 meters. So its span is basically 80 meter, and the central sag is given as a 8 meter, which I have shown you in figure. This central sag, you can see here, is given as a 8 meter. So what we have to determine, determine maximum tension in cable, also forces on the tower if the cable is supported by saddle and pulley, which are stayed by the wires inclined at the 30 degree to horizontal. For both cases the angle of inclination is 30 degree. So let's see how we can solve this example. So as I've told you that cable is subjected to UDL. So in our previous video, in our first video of our arches and cable, we have derived the equation for horizontal reaction, and we are calculating the vertical reaction same way which we are doing for a beam. So as you can see here, vertical reaction will be what, as the cable is throughout loaded with UDL, so the reaction at the both end will be WL by 2. Okay, it's a symmetric, so it will be WL by 2. Now the horizontal reaction. For horizontal reaction, if you haven't seen the previous video, I would suggest you to see the first video of our arches and cable, which is a basic introductory portion. So even if you haven't seen that video, let me show you just the equation of a horizontal reaction. So here it is our equation. You can see H is equal to WL square upon 8H, where H is our nothing but sag, central sag, W is our load, and L is our span. So same way we can calculate the horizontal reaction by using this equation, or we can calculate by taking moment. So either way you can you can calculate the horizontal reaction. So here I have used the equation H is equal to WL square by 8H. So here we have given the central sag of 8 meter. So our H will be 8 meter, so 8 into 8, 64. W is what, 30 kilonewton per meter, and L, which is our span, which is given as 80 meter, so 80 square. So our horizontal reaction is of 3000 kilonewton. So once we have calculated our VA, and which is the vertical reaction, and the horizontal reaction, we can determine the tension in our cable by taking the resultant of our these two forces, which you have already studied in your applied mechanics. So we can calculate our maximum tension. See here, they have calculated, they have mentioned that calculate maximum tension. So as I've told you that maximum tension will be at support, so we will utilize the value of a vertical reaction and a horizontal force. So see here, T maximum will be V, where V is our vertical reaction, H is our horizontal reaction what we have determined. So 1200 square plus 3000 square is equal to 3 to 31.1 kilonewton. This tension is for cable. Okay, so next thing which we have to determine is that how much amount of reaction, or you can say load, which will occur at the tower, on a tower. So for that, first of all we have to determine our theta. Okay, we have given the value of alpha. See here, let me show you. See here, uh, here you can see that forces on an anchor, cable and tower. So here we have given two cases when our cable is passing through a pulley or passing through a saddle. So for our pulley system, or you can say when cable is passing through a pulley, so there will be two kind of reaction will be generated. The one will be horizontal reaction and the second one will be our vertical reaction. So there will be two kind of load transmitted on a tower will be vertical and the one will be horizontal. So here is its equation. We are directly going to test the equation. We are not going to solve or derive it. I have already shared you this book, you can see in it. And suppose that if our, you can see here, there will be one theta and one alpha. Now as I have told you that we have to when we are adopting such kind of cable or a suspension bridge, the cable which is passing over a tower which has to be anchored to a strong foundation. So there will be two part, the main cable and anchor cable. So there will be two different angle. So the angle which cable made with the assumed horizontal phase is alpha, and the angle which is made by a main cable to a assumed horizontal phase is our theta. So here we have given the value of angle, so we will utilize that. And the same way for a roller support, or you can say a saddle, when there is a saddle is provided on the top of a tower, so you can see it's a kind of roller support. So there will be only a vertical reaction will be there because it's a kind of roller system. So in a roller support we generally see that there is only one vertical reaction is there, so there will be no horizontal reaction. So only vertical reaction will be there, and its value is given here. So there will be two different forces in a two different cable. So T will be tension will be in main cable, and T1 will be anchor tension in anchor cable. So we have to determine these two value. So now we will utilize these two equation in order to determine the forces acting on a tower. So before going to that, as I told you that they have given us the angle which is made by anchor cable, which is 30°. So we have to find out first of all the theta. So the theta we can derive by taking angle. So h, as we know that our h is what, T max cos theta. So you can see in our first video of cable and arches, there will be there I have shown you the equation of h. So h is over what, T max cos theta. and theta will be cos inverse h by t. So our theta will be finally 21.80 degree. So now we have alpha and our theta, so we can utilize the equation for a pulley system. So vertical force in a tower will be how much? T max sin alpha plus sin theta. You can see here for pulley system. So what will be our vertical force? It is T sin theta plus sin alpha. So here T sin alpha plus T sin theta. So our T max we have already calculated, which is 31.1, as you can see here. So sin alpha is 30 and theta we have derived 21.80 degree. So our vertical force which is transmitted on a tower is how much? 2815.48. Same way horizontal force, we have the equation T cos theta minus cos alpha. So you can see here T cos theta minus cos alpha. So after putting the value, T max is equal to 3231.1 and cos theta, where theta is 21.8 degree and alpha is 30 degree. So you will get the horizontal force on a tower is 201.82 kilonewton. So now we will do the calculation for our saddle system. So for saddle system, as I told you that basically it's roller support. So in roller support we are generally having one vertical reaction and no horizontal reaction, or you can say no horizontal forces. So we only have one vertical component here which is acting on a tower. So for our roller support, or you can say saddle, first of all we have to determine our T1 and then we will find our vertical force on tower. So see here, equation of T1 is what? T1 cos alpha is equal to T max cos theta, where alpha is 30 degree which is given in our example, and cos theta we have determined our theta. So our T1 will be 3464.1. So now by using this T1 we can determine our vertical force which is acting on our tower. So by using the equation for vertical force on tower, see here T1 sin alpha plus T sin theta. So by using that equation, our vertical force on a tower for T1 of 3464.1 sin 30 degree plus 3231.1 sin 21.80 degree, so 2931.98, which is vertical force transferred on a tower. Suppose that if we are providing roller or a saddle. So in this system, you can see that here uh, our forces are, we have considered that our forces are same in a pulley system, T max. Okay, but in our roller system it is not going to be same. So we have to first of all find out T1 and then we will go for our main equation which is for vertical force in tower. So this way we can do the analysis of our cable and towers when cable is subjected to uniformly distributed load. So in our next session we will go for cable which is having its support at different end. So thank you, and if you have any query you can ask me in our query session. Thank you.